Hello friends. So in this video series, we're going to discuss about a set of questions which has a better method of solving it rather than the conventional method. Okay, so first we will start with that of a conventional method of solving it, followed by that of the shortcut method. So this question that we are going to discuss is on your secondary screen. You can see the screen. So here in this question, it is given that the matrix Q is orthogonal and the Q is given as 3 by 7, 2 by 7, 6 by 7, minus 6 by 7, 3 by 7, 2 by 7, 2 by 7, 6 by 7, minus 3 by 7. And the question is about finding the inverse of the matrix Q. So first we will discuss about the conventional way of solving it, which is nothing but, the inverse is nothing but the adjoint of Q divided by the determinant of Q. So how to find the adjoint? To find the adjoint, so first of all we have to find the minor matrix, minor of this particular matrix, then followed with it of the cofactor, and finally it's going to be the adjoint. So that is how we find the adjoint matrix, and the determinant of the matrix is also what we have to find. Right? So this particular question belongs to the topic of linear algebra. This particular question belongs to the chapter of linear algebra, and the topic is the inverse of the matrix. So first of all, how to find the minor matrix? So how to find the minor? So minor of a particular element. So any element that you consider, for example, if I want to find the minor of this element, I don't want to consider the row and the column in which it is going to belong. I will cancel it out. And the determinant of the submatrix resulted after the cancelling the row and column is what we call as the minor of this particular element. Now which is equal to that of minus 9 minus 12, which is equal to minus 21 by 49, which is minus 3 by 7. And similarly, when you want to find the minor of this element, so you should not consider the the column and the row with which it is going to belong. So in that case, it is going to be 18 minus 4, 14 by 49. So it is going to be 2 by 7. So in that way, we will find out all the minors of each and every element. So it is going to be minus 3 by 7, 2 by 7, minus 6 by 7, minus 6 by 7, minus 3 by 7, 2 by 7, minus 2 by 7, 6 by 7, 3 by 7. So once you find the minor, and then you find the cofactor matrix. Now how to find the cofactor matrix is that for a 3 by 3 matrix, the rounded off elements, these elements have to be multiplied with minus 1. So when you have a 3 by 3 matrix, so these elements, okay, these particular elements have to be multiplied with a minus sign. Whereas the formula says that when you know the minor, so mij minus 1 power I plus j is going to give you the cofactor matrix. So simply speaking, all these elements are not going to change, only the rounded elements are going to change their signs. So which is going to result in, okay, so this element becomes minus, this element becomes plus, this element becomes minus, and this element becomes minus. So once you find a cofactor, the transpose of the cofactor is going to give you the adjoint. Now once you find the adjoint, you have to only find the determinant. So the determinant is given by 3 by 7 into minus 3 by 7 minus 12 by 7, okay, and minus 2 by 7, minus of this particular element 2 by 7 into 18 minus 4, which is 14 by 49, plus 6 by 7 into, right, minus 36 minus 6, which is minus 42 by 49. So the total it is going to be equal to the top minus 63 minus 28 minus 252 after taking 343 as common in the denominator. So the total it is going to be equal to the top minus 1. So the Q inverse is nothing but minus 1 times the of the adjoint matrix. So once you multiply the adjoint with a minus sign, you are going to have 3 by 7 minus 6 by 7, 2 by 7, 2 by 7, 3 by 7, 6 by 7, 6 by 7, 2 by 7, minus 3 by 7. So which is matching with the top option C. But in the examination, we will not have this much amount of time. Once they are asking of inverse of a matrix, which is slightly, because of the new denominator which is present here, it becomes slightly complicated. But something that is given about this particular matrix is, it is an orthogonal matrix. Now once the matrix is orthogonal in nature, it will satisfy the condition that Q into Q transpose is equal to that of the identity matrix. This is the property that is satisfied by that of the identity matrix. Q into Q transpose is equal to that of I. So which implies that the Q transpose will be equal to that of Q inverse once the matrix is a invertible in nature. So Q transpose has to be equal to Q inverse. It means that Q inverse will be equal to that of Q transpose. It is very simple to find the transpose of a particular matrix. So once you have a particular matrix Q, you can find the transpose of it. So once you find the transpose, it will be equal to that of inverse in the case of the orthogonal matrix. So therefore, Q transpose is equal to Q inverse is equal to what? It is equal to 3 by 7 minus 6 by 7, 2 by 7, 2 by 7, 3 by 7, 6 by 7, 6 by 7, 2 by 7, minus 3 by 7. So this is nothing but the inverse of the particular matrix. Okay, so the answer is matching with the option C.